What if I told you that the gold in this ring was made when two dead stars smashed into each other at nearly the speed of light, billions of years before Earth even existed? That probably doesn't sound real, right? But it's true. And honestly, it's one of the most fascinating things I've ever learned. Hey everybody, I'm Michelle, and welcome to Wondering Why. If you've been here before, you know this channel is all about exploring things that I'm curious about. Today, though, I wanted to talk about something I'm really passionate about, which is astronomy, specifically stars. I've been doing research in astrophysics for the past couple of years, and along the way, I've come across some facts that genuinely made me stop and go, wait, what? So I just wanted to share a few of those with you today, because I think once you hear them, you'll never look up at the night sky the same way again. All right, let's get into it. So, you've probably heard the phrase, we are all made of stardust. It sounds poetic, right? Like something you'd see on a poster. But it's not just a nice saying, it's literally, physically true. And here's why. When the universe began with the Big Bang 13.8 billion years ago, the only elements that existed were hydrogen and helium. That's it, the two simplest atoms. There was no carbon, no oxygen, no iron, no gold. None of the stuff that you, me, this planet, or anything we know is made of. So you might be wondering where everything else came from. And the answer is stars. Here's how. A star is basically a giant ball of hydrogen gas, and at its core, the temperatures are so extreme, we're talking millions of degrees, that hydrogen atoms get slammed together hard enough to fuse into helium through a process called nuclear fusion. That fusion releases a ton of energy, which is why stars shine. That's what our sun is doing right now, turning hydrogen into helium, and it's been doing that for 4.5 billion years now. But bigger stars, stars that are like 8, 10, 20 times more massive than our sun, they don't just stop at helium. When they run out of hydrogen in their core, gravity squeezes the core even harder, the temperature goes up even more, and the star starts fusing helium into carbon. Then carbon into neon, neon into oxygen, oxygen into silicon. And here's what's cool about this. Each of these stages happens faster and faster. A massive star burns hydrogen for millions of years, but it burns through helium in maybe a million. Carbon lasts a few thousand years. And silicon, the very last stage, burns through all its fuel in about 1 day. That's right. After millions of years of fusion, the final stage is over in just 24 hours. And the element it produces at the very end? Iron. And that's where things get really interesting. So every fusion reaction up until this point has released energy. That's what keeps the star alive. The energy from fusion pushes outward and holds the star up against its own gravity. It's like a perfect balance. Gravity wants to crush the star. Fusion pushes back. And for millions of years, they're in this tug of war. But iron is different. Iron is the most tightly bound nucleus in nature. Infusing iron doesn't release energy, it actually absorbs energy. So the star has been running on fusion power for millions of years, and it just produced the one element that kills the engine. The iron core just sits there, growing heavier. And once it gets big enough, about 1.5 times the mass of our entire sun, packed into a space about the size of Earth, the core can't hold itself up anymore. And what happens next is the single most dramatic event I think I've ever learned about in all of science. The core collapses. And when I say collapses, I mean an object roughly the size of Earth, thousands of miles across, crushes down to a ball about 12 miles across. the size of a small city, and it happens in less than 1 second. Some calculations even put it at about a quarter of a second. Just think about that for a minute. A stellar scale object, something so massive it has 1.5 times the mass of the sun, collapsing from Earth size to city size in the time it takes you to blink. The material falling inward is moving at something like 70,000 kilometers per second, nearly a quarter of the speed of light. All that material slams into the newly formed core, which is now a neutron star, basically one giant atomic nucleus, and it bounces. That bounce sends a shockwave rippling outward through the rest of the star, and the entire thing explodes. A supernova. And for a few weeks, that one single exploding star can outshine an entire galaxy of hundreds of billions of stars. And speaking of supernovae, you might have one in your backyard. Well, sort of. If you've ever looked up at Orion, one of the easiest constellations to spot, that bright reddish star on the upper left is called Betelgeuse. It's a red giant. It's absolutely enormous. And if you put it where our sun is, its surface would extend past the orbit of Jupiter. And it's nearing the end of its life. Astronomers think Betelgeuse could go supernova sometime in the next 100,000 years, which in cosmic time is basically any minute now. If it did, it would be visible in broad daylight for weeks, and at night it would be brighter than the full moon. You can literally read a book by the light of an exploding star. Back in 2019, Betelgeuse actually dimmed dramatically, and everyone kind of freaked out for a second, thinking, is this it? But what actually happened was that the star had ejected a huge plume of hot gas from its surface. And as that gas moved away and cooled, it condensed into a cloud of dust that partially blocked Betelgeuse's light from our view. So it wasn't really dying, it was basically just hiding behind its own exhaust. But still, every time you look up at Orion, you're looking up at a star that is going to explode someday. We just don't know exactly when. So we've talked about how stars forge elements up to iron through fusion. But look at the periodic table. There's lots of elements heavier than iron. Gold, platinum, uranium. If fusion can't make them, because fusing anything past iron takes energy instead of releasing it, then where do they come from? And the answer is from some of the most violent events in the universe. Some heavy elements get forged in the explosion of the supernova itself. The temperatures and pressures in that blast are so extreme that heavier elements get smashed together. But for the really heavy stuff, like gold and platinum, we need something even more extreme. And that something is neutron star collisions. Remember those neutron stars, the tiny city-sized remnants left over after a core collapse? Sometimes two of them end up orbiting each other, spiraling closer and closer together until they merge. And when they collide, it's so incredibly violent that it creates a burst of heavy element production. Scientists estimate that a single neutron star merger can produce something like 10 Earth masses worth of gold, all from one collision. So, that gold ring I showed you at the beginning, those atoms were forged billions of years ago when two dead stars crashed into each other somewhere in our galaxy. The debris drifted through space, got swept up into the cloud of gas that eventually became our solar system, and ended up here, on your finger. That's a pretty wild origin story for a piece of jewelry. One more thing that I think is really counterintuitive about stars. You'd think that a bigger star with way more fuel would live longer, right? More gas to burn through, so more time. It's actually the opposite. Massive stars burn through their fuel way faster because the gravity at their core is so much stronger, which means the temperatures are higher, which in turn means that the fusion reactions run at a much faster rate. A star like our sun will live about 10 billion years, A star 10 times more massive, maybe 20 million years. And the absolute biggest stars, 100 plus times the mass of the sun, might only last 2 million years. They live fast and die young, as Lana Del Rey would say. And they die spectacularly in those supernovae we just talked about. The biggest stars have the shortest lives and the most dramatic deaths. And here's the part that ties everything together and honestly makes this whole story feel complete. When a star explodes as a supernova, all those elements it spent millions of years building, the carbon, the oxygen, the iron, get blasted out into space. And that material mixes into the gas clouds around it. Sometimes the shockwave from the explosion is actually what triggers a nearby gas cloud to start collapsing and forming new stars. So, a star dies, and from its death, new stars are born. But now, those new stars and their planets are made from a richer mix of elements. Our sun is probably a third-generation star. The cloud it formed from had already been enriched by at least 2 generations of stars that lived and died before it. It's like this cosmic cycle of birth, death, and rebirth, almost spiritual in a way. Everything gets recycled, and nothing is wasted. And we are part of that cycle. The calcium in your bones was made inside a star. The iron in your blood was the last thing a massive star ever created before it died. The oxygen you're breathing right now was forged in a stellar core that burned out before our sun was even born. We are, literally, not poetically, but literally, made of stardust. So, yeah, those are some of the things I've learned about stars that really stuck with me, and I just wanted to share them with you. I hope you found them as amazing as I did. If you like this video, please consider subscribing to Wonder and Why. I'll be sharing more stuff like this, along with other STEM topics that I think are really cool and worth knowing about. Drop me a comment too. What's the most interesting space fact you've ever learned? I'd love to hear it. Thank you for watching, and I'll see you guys in the next one.